Hey guys, it's Mr. Brengle, and I'm going to be going over the net force particle model practice quiz for the math that you took in class. So this problem says that a 20 kilogram rock is dropped off the top of a building. It accelerates downward at 3 meters per second squared. We need to draw a force diagram for the situation and solve for the drag force or air resistance acting on the rock. So we are going to go ahead and make our force diagram right over here. We know that the force due to gravity points down, and we know that drag force is pointing up. Now, because it's accelerating down, and this was not drawn to scale, really this should be longer, FG must be larger than FD because it's accelerating downward. So in order to solve for the drag force, we need to do a sum of the forces in the x direction, the y direction. And because it's accelerating, we write it as sum of the forces in the y direction is equal to mass times acceleration. So if the positive direction is up, we would say FD minus FG is equal to mass times acceleration. So we will go ahead and add FG to the other side. So mass times acceleration plus FG. Now when I put the numbers in here, you got to be careful because remember that it's accelerating downward, so that acceleration value is going to be negative. We've got 20 kilograms times negative 3 meters per second squared plus FG, which would be 20 times 10, which is 200 newtons. So when you do this math, you've got 200 minus 60, and you're going to end up with a drag force of 140 newtons. And this should make sense, right? The drag force is less than 200 newtons, so the object has a net force pointing down, and it will accelerate down. Let's move on to number 2. This one says a 25 kilogram water skier is accelerating to the right as she is pulled by a speedboat. The boat pulls the skier with a force of 120 newtons. The drag force, or friction, opposing the skier's motion is 65 newtons. Draw a force diagram for the situation and solve for the skier's acceleration. So for our force diagram here, we know that the skier is being pulled to the right, so I'm going to call this FP. If you want to call that tension force FT, that's also fine. We've got drag going to the left, or the friction opposing the motion, but we do know that the pull force, or the tension force, is larger than the drag force. And then of course we've got FG and FN, which are equal in this case. Now, to solve for the acceleration, we need to do a sum of the forces in the x direction and set that equal to mass times acceleration. So since the object is moving to the right, we want to use that as our positive direction. So FP minus FD is equal to mass times acceleration. And if we're solving for acceleration, we would divide by the mass, and this would rearrange to the pull force minus the drag force divided by the mass. So it says that the pull force is 120 newtons minus the drag force, which is 65 newtons, divided by the mass, which is 25 kilograms. When you do this calculation, you will find an acceleration of 2.2 meters per second squared. Whoops, there we go. On to number 3. A 5 kilogram ball accelerates down a hill that makes an angle of 35 degrees to the horizontal. The frictional force is 10 newtons. We need a force diagram and to solve for the acceleration. So you should have a diagram on your paper, but the force diagram, the ball is going down the hill to the right. get our x and y axis on here. Fg, Fn, and the frictional force that opposes the motion. Okay, so when we make our triangle here, remember it needs to make a right angle with the y-axis. And then this angle up here is 35 degrees. Since the opposite side is down here, we will label this Fg sine theta, and then the adjacent side is Fg cosine theta. Now that we've got our force diagram, we can go ahead and do this problem. Again, the object is accelerating in the x direction, so that's what we want. Sum of the forces in the x direction is equal to mass times acceleration. Now, whenever we're doing this, tend to get a lot of questions on this. We're looking at this line right here. This is our y-axis, this red line. Anything to the right of that is positive. Anything to the left of that is negative. So right here, Fg sine theta is to the right of that in the x direction. That will be our positive value. So Fg sine theta minus our negative value, which is going to be the frictional force over here because it's pointed in the left direction on the x-axis. This is going to be equal to mass times acceleration. And again, to rearrange this, it would be Fg sine theta minus the frictional force divided by the mass. So 5 kilogram ball has a weight of 50 newtons times sine of 35 minus the frictional force, which the problem states is 10 newtons. Divide all that by the mass, which is 5 kilograms. And when you do this math, you are going to get an acceleration of 3.74 meters per second squared. Last one. All right, so on this one we've got a person towing a wagon to the left on a level sidewalk, but the towing force or the pull force is angled up and to the left at an angle of 25 degrees to the horizontal. And again, your quiz should have the picture on it. So let's go ahead and draw a force diagram here. Don't make the mistake of putting this on an incline. It's on a level surface. So just like normal, we've got Fg, we've got our frictional force opposing the motion of the wagon, we've got Fn, which is balanced with Fg, and then really it's this tow force right here, or I'll call it Fp for F pull. This is what we're interested in. We're going to make our triangle with the angled force. And I do want to make it on this side here instead of here because we've already labeled this side with the normal force, and we don't want to have two labels on this. So it says a 25-degree angle with the horizontal, so that's going to be down here, 25 degrees. And then this is our adjacent side down here, so this is going to be Fp cosine theta. And then our opposite side is going to be Fp sine theta. So we've done A, we've got our force diagram. Now we need to solve for the acceleration, so it is going to be in the x direction. And since the wagon is moving to the left, I want to say that Fp cosine theta is my positive value because it's on the left side of the y-axis here. And then the frictional force is my negative value because it's on the right side of the y-axis. So Fp cosine theta minus the force due to friction, that's equal to mass times acceleration. We'll go ahead and divide by mass to get acceleration by itself. And now we can plug our values in. So the pull force, it says, is 200 newtons times cosine of 25 degrees minus the frictional force, which is 80 newtons, divided by the mass, which is 70 kilograms. When you do the math here, you are going to get an acceleration of 1.45 meters per second squared. Okay, so that's for part B. Then for part C, solving the normal force of the wagon, we want to do a sum of the forces in the y direction, but this time it's equal to 0 because the wagon's not moving up or down. So with this, again, we need to be careful here. You know that Fn is a positive value. That's nothing new. We know that Fg is a negative value. However, this angled force over here has a vertical component to it. And since it is above the x-axis here, it's above this line, this Fp sine theta is also going to be a positive value. And we do need to account for that in our equation. So we're going to say that the normal force plus Fp sine theta, because they're both positive, minus Fg is equal to 0. And if it helps you, Fn is pointed up, Fp sine theta pointed up, Fg pointed down. Now, we're solving for Fn, so let's go ahead. We need to add Fg to the other side, and we need to subtract Fp sine theta. So it's going to be Fg minus Fp sine theta on the other side. Fn is equal to the weight of the wagon, which is 700 newtons, minus the pull force, which is 200 newtons, times sine of 25 degrees. And when you do this calculation, your normal force is going to come out to be 615.48 newtons.